Bismillah ar-Rahman ar-Rahim. We'll continue. That was the last one we did. Now let me continue. If the inflection point happen at this, then the possible value of B is. We'll do the same. By the way, the domain of F is what? Or real number, because this cannot be 0. So I have F prime. We need to be careful with F prime. It's 2x plus 1 times the denominator minus 2x x plus 1 square over 1 plus x square. Is x plus 1 square? I can rewrite it as x square plus 2x plus 1 to save time. So that will be what? 2x cubed plus 2x square plus 2x plus 2 minus 2x cubed minus 4x square minus 2x over this. Note this cancelled and this cancelled. And we're getting what? 2 minus 2x square over this. Okay. Yeah. Now we'll do F double prime. I'm getting what? Minus 4x times this minus this. I can rewrite it as 2 1 minus x square derivative of this. What is that? 2 1 plus x squared to the power 1 times 2x. Over this is the power 4. And that will be equal to what? I can take minus 4x 1 plus x squared is a common factor. So also I have here 4, 2 and 2, and 1 plus x squared. We also have the x here. Okay. What you will get from here, we have 1 plus x squared. Note I took minus 4, so minus, this is gone, this is gone, this is gone, this is gone, x gone. What's the remaining? 2 times 1 minus x squared. Okay. Over this. This is cancelled. This is becomes 3. So I have minus 4x. What is here? I have 3 minus x squared. All of this. Oh. So I have equal 0. Give me x equal 0 or x equal plus or minus square root of 3. Yeah. Is it inflection point? We'll check. This is minus square root of 3. This is 0 plus square root of 3. Okay. This is always positive. No worries. Take minus 2. It will be negative. Negative, negative. Then all of this is negative. Take minus 1. That will be positive, negative, positive. Take 1. It will be positive, positive, negative. Take 2. It will be negative, positive, negative. That make it positive. So inflection point here, inflection point here, inflection point here. So the answer will be 3. 3 or 0, but because that he said the possible value. Okay. Yeah, calculation just calculation are not easy. Okay. The graph of the function is concave downward in the interval. خلاص. What you will do? We need f double prime. So I have f prime. That will be minus 2x times 24 over this square. Or you know what? I can make it. Yeah. Powers. It will be easier, I think. If I make f of x as 24 x squared plus 12 to the power minus 1. Note domain of f is already a number. Huh? I have no restriction. F prime would be what? Would be minus 24 x squared plus 12 to the power minus 2 times 2x. In other words, minus 48x x squared plus 12 to the power minus 2. F triple, F double prime, product rule, minus 48 minus 48x times minus 2 times x squared plus 12 to the power minus 3 times 2x. Okay, now we'll take common factor. I'll take minus 48 times x squared plus 12 to the power minus 3 as a common factor. What's the remaining here? X squared plus 12. Okay. There, this is gone. This is gone. So what's the remaining? Minus 4 x squared. Minus 4 x squared. Okay. X minus 2x minus 4 x squared. So the answer is minus 48. This will be what? 12 minus 3x squared. 12 minus 3x squared. Over this. I have f double prime equals 0. It gave me x will be equal plus or minus 2. Okay. So I plug minus 2 and 2. The domain already a number, so it's there in the domain. And check. This is always positive. So take minus 3. Minus 3, that give me minus 27. 12 minus 27 is negative. That is negative. That will be a positive. Take minus, or take 0. It will be easier. 0 will be negative. Take 3, it will be positive. So it's concave down here. Minus 2 to 2. The number of inflection point for the graph of this. Same idea. What's the domain first? From 0 to infinity. 0 is not included. Okay. F prime would be equal to what? Minus square root of x minus 6 minus x 1 over 2 root x over x. And that will be over 1. That give me what? I have 2x root x here. And I have minus 2x. Okay. Minus 6 plus x. So it will be, let me be sure, 6 minus x, the derivative is minus 1 times the denominator minus the numerator times the denominator. Okay. Now it will be 2 root x there. I have minus 2x. And this is minus 6 plus x. Okay. So I have what? Minus x minus 6. When I make it 2x in the power 3 over 2. Make it easy. Okay. F double prime will be what? The numerator minus 2x to the power 3 over 2 minus x minus 6. Derivative of this, which is 3x to the power 5 over 2. 3x to the power half over 4x cubed. Okay. Now we take common factors. With the common factor, it will be x to the power half. What's the remaining? Minus 2x plus 3x plus 18. Correct? Yeah. Over 4x to the power 3. So it will be x to the power half times x plus 18 over 4x cubed. If double prime equals 0, I'm getting what? X equal minus 18, which is not in the domain of f. Okay. 0 is not in the domain, so I have from 0 up to infinity. So 0 cannot be inflection because there is nothing to the left, just to the right. So the number of inflection point is 0. Okay, now let me go to the questions from the book. We try to do as much as we can, including the suggested problems. Okay, in exercise 3 to 14, determine the open interval in which the graph is concave up or concave down. So I need to check concave up, concave down. Okay, 4. Yeah, 4. G of x is 3x squared minus x cubed. Okay, we'll find G prime, 6x minus 3x squared. G double prime, 6 minus 6x. G double prime equals 0. Lies x equal 1. Take 1. Left, right. Take 0. It will be positive. That will be negative. That's concave up, concave down. So it's concave up, minus infinity to 1. Concave down from 1 to infinity. Okay, number 6. H of x to the power 5 minus 5x plus 2. Okay. Let us do h prime. That will be 5x to the power 4 minus 5. H double prime. That will be 20x cubed. Make it equal to 0. I'm getting x equals 0. Put the 0. This is negative. This is positive. Concave down, concave up. Yeah. So it's from minus infinity. Concave down, minus infinity to 0. Concave up, 0 to infinity. Okay, the easy one. This is easy ones. Okay, now the functions are becoming a little bit complicated. No, it's not that complicated. It will be okay still. 10 f of x plus 8 over x minus 7. Yeah. We'll do f prime. Yeah, well, the thing is the calculation. It will be x minus 7 minus x minus 8 over x minus 7 square. That will be minus 15 x minus 7 square. F double prime would be what? The 0. That will be 15 minus 15 times 2 x minus 7 over x minus 7 to the power 4. This is 3, this is cancelled. So you have 30 over x minus 7 to the power 3. Okay, what's the domain of f? All real numbers minus 7. And they have point of discontinuity at 7, so we'll make it with 7. And before 7, take a negative, that will be negative, that will be positive. So it's concave down and concave up. So I can say concave down minus infinity to 7. Concave up 7 to infinity. Okay, 12. H of x squared minus 1 over 2x minus 1. As you know, this is the only thing, the only changes, and with that, the calculations are becoming a little bit complicated. So we'll do h prime will be what? 2x times 2x minus 1 minus 2x squared minus 1 over 2x minus 1 square. That will be what? 4x squared minus 2x squared, that will be 2x squared minus 2x plus 2 over this. Okay. I'll do f double prime or h double prime. I think that will be complicated. Now that will be what? 4x minus 2 times this. Let me give it more space. Okay, so h prime of x will be equal what? 4x minus 2 times this one minus all of this derivative of this, which is 2. Okay. And take 2 and 2x minus 1 common factor. What's the remaining? Here I have what? If I take 2, I have 2x minus 1 times 2x minus 1. Interesting. Really? Yeah. Don't forget I took 2 here. Minus. This is cancelled. This 2 cancelled. So I have minus 2, 2x squared minus 2x minus 2. All over 2x minus 1 cubed. Cubed, is it? No, to the power 4. Okay. So this is becomes here 4. It becomes 3, and this is cancelled. So what we have? We have 2, 4x squared times 2, that 8x squared. Sure. Took 2 to x minus 1. I took 2x minus 1 common factor and 2 to be sure only 2 to x minus 1. The remaining is this is what? This is 2 to x minus 1. Okay, so I have 2x minus 1 times 2x minus 1. Okay, and here I have this is gone, this is gone, this is gone. I took 2 to x minus 1. The remaining is 2 times 2x. This is plus 2, sorry. It's plus 2. So this is plus 2. Yeah, that will not make a big difference. Now I have what? 8x squared. No, it cannot be. Minus 2x minus 4x. Let me see what will happen. Minus 8x. V2 missing. Somewhere. There is a 2 missing somewhere. Yeah. Let me do it again. I had calculation. Okay. This is h prime. 2x squared minus x plus 1. So let me write it this way too. Okay, by the way, the domain or real numbers minus half. Well, at half I have point of discontinuity. Now let us put that in our mind. This is not the main point. Okay. H double prime. It will be derivative of the numerator, which is what? 4x minus 2 times the numerator, the denominator, minus the numerator, which is 2, derivative of this, 2, derivative of this, which is 2, over okay. I took 2 and 2x minus 1 common factor. What's the remaining? The remaining is, this is what? This is 2x minus 1. The remaining is 2x minus 1 square minus 4x squared minus x plus 1. Okay, over this. By the way, this is going to cancel, this is cancelled. So we have 2 times what? 4x squared minus 4x plus 4 minus 4x squared plus 4x minus 4. Wait a minute. This is plus 1 minus 4 this is cannot be, this is not the same as this. So it's minus 4x squared plus 4x minus 4. Okay, there's 4x squared. Oh, plus 1. Sorry. This is plus 1. Yeah, this is plus 1. Yeah, calculation not easy. 2x minus 1 cubed. This is cancelled. This is cancelled. So that gives me minus 6 over 2x minus 1 cubed. Oh, now I have only the minus the half, and before half, this is positive, this is negative. So it will be concave up from minus infinity. Yeah, from minus infinity to half, and concave down from infinity to from half to infinity. Yeah, notice here, if double prime cannot be equal to 0. Minus 6 cannot be equal to 0. Yeah, as I said, the main difficulty comes from the calculation. The rest is nothing to worry about. Okay, 14. What is 14? Y equal x plus 2 over sine x, and from minus pi to pi. Okay, and that is what? X plus 2 cosecant x. So it will be y prime. Y prime will be 1 minus 2 cosecant cotan. Okay. So y double prime, this is 0, will be what? Will be minus 2. Okay. Now, product rule, cosecant is what? Minus cosecant, cotan. I took the minus 2 out, so I'm dealing with this, huh? Which is my plus cosecant, cotan minus cosecant square. That's it. There's nothing more. So that will be what? I can take minus cosecant outside, so that will be 2 cosecant x times what? Cotan square plus cosecant minus cosecant cotan, cotan cotan x plus cosecant minus cosecant square. It will be cotan square. I took 2 cosecant outside. I took 2 cosecant outside. 2 cosecant can take outside. And the remaining is cotan square plus cosecant square. And with that, 1 plus cotan square equal cosecant square. So that gives me what? 2 cosecant x. This is 1 plus cotan square. So it will be 1 plus 2 cotan square x. I know. Minus 2. This is minus cosecant cotan. Minus cosecant cotan times cotan plus cosecant divided by cotan minus cosecant square. So I took cosecant outside. That give me what? I took cosecant outside with the minus sign, so I have cotan square plus cosecant square. Okay. And 1 plus cotan square equal cosecant square. So I have this 1 plus 2 cotan square x, which is none of them will be 0. Yeah. So this is impossible to be 0. Okay. But be careful. When you have this, I need to avoid that sin x equals 0. So this is impossible to be 0. This is always, this is non-zero. This is non-zero. But be careful. Point of discontinuity are what? I have it when sin x equals 0, which means x equals 0. Since I have the interval open, minus pi to pi. So only 0. So I'll put 0 here, which is open. And this is minus pi, and this is pi. Okay. I check the sign for this. This is always positive. Just I need to check cosecant. Cosecant in this third and fourth quadrant is negative. This is positive. So it's concave down from minus pi to 0, and concave up from 0 to pi. The thing here, the calculations. There is never 0, there is never 0. But I need to consider always the point of discontinuity. Yeah. But as I said, usually the difficulty comes from the functions. Now, point of inflection. Let me start with easy ones. Oh no, function. We have 15 to 36. Yeah, I choose many functions. This is the complete. I need to find f double prime. That's the biggest problem. You need to find f double prime, which is make it very complicated. Okay, 16 minus x cubed plus 6 squared. I'll do it here. Minus f of x. They call it f, or they call it what? F minus x cubed plus 6 squared minus 5. What will be f prime? Do the derivative. That will be minus 3x squared plus 12x. F double prime will be minus 6x plus 12, which is very clear. This will be minus 6x minus 2, which is equal to 0, implies x equal to. So I'll put the 2 The domain is all real numbers, so nobody to care about, nothing to care about. So it's plus minus, and this is concave up, this is concave down. It means what? I have a point, this is a point of inflection, which is the point of inflection will be 2, and substitute here, minus 8, minus 5, minus 13, plus 24, that will be 11. Okay, that is 16, not difficult. 15, 4 minus x minus 3x. 17, what is this? 18. That is 18, not 15. 18. What is it? 4 minus x minus 3x to the power 4. Yeah. The same thing, we'll find f prime. That will be minus 1 minus 12x cubed. We'll find f double prime. That will be minus 3x squared. F double prime equals 0. So you have x equals 0. I'll put the 0. That will be negative, negative. So 0, no point of inflection. No change of concavity. No point of inflection. 0 is not the point of inflection. Okay. 20 x minus 2 cubed times x minus 1. I don't think the space is enough, so I'll do it here. 20 f of x minus 2 cubed times x minus 1. F prime would be what? Would be 2, 3, I mean. Product rule. X minus 2 squared times x minus 1 plus x minus 2 cubed. And that gives me x minus 2 squared times 3x minus 1 plus x minus 2, which is what? X minus 2 squared times 4x minus 5. Okay. Second derivative, I mean. I have 2x minus 2 for x minus 5 plus 4x minus 2 squared. So I have 2x minus 2 common factor. What's the remaining? 4x minus 5. 4x minus 5 plus 2x minus 2. That give me what? 2x minus 2, 6x minus 9. Can take 3 common factor. I have 6x minus 2, 2x minus 3. Okay. So f double prime equals 0, plus x equal 2, or x equals 3 over 2. Like this. I have 3 over 2. I have 2. Now to check the sign of this function. 0 give me positive. Between 3 over 2 and 2, I have what? 1 3/4. That will be negative. That will be positive. So it will be negative. More than 2, it will be positive. So it's concave down, or concave up from minus infinity to 3 over 2 and 2 to infinity. Concave down from 3 over 2 to 2. Okay. What is the point of inflection? Is there a point of inflection? Yes. This is inflection point, and this is inflection point. So we have 2 points of inflection. And you can find the calculation, you can find them with the F at. So the inflection point will be 2, and we substitute here, you got 2 and 0, and 3/2, and substitute here, it will be what? Minus half, that will be minus 1/8, times half, that will be minus 1/16. Okay, 22. Now the functions becomes a little bit complicated. X square root 9 minus x. What will happen? Do f prime. Yeah. That gives me square root 9 minus x plus x 2 square root 9 minus x times minus 1. All of this over, no, not this. That will be what? 2 9 minus x over 2 square root 9 minus x. And that give me what? 18 minus 3x over 2 root 9 minus x. By the way, what's the domain of the function? X is than equal to 9, and is not equal to 9. Okay. Now, if double prime, I need to do it carefully. That will be minus 3 to square root 9 minus x minus 18 minus 3x times 2 times minus 1/2 square root 9 minus x. This is cancelled. All of this is square for 9 minus x. And that give me what? Yeah. I have minus 6 times 9 minus x plus 18 plus minus 3x over 4 minus 9 minus x square root 9 minus x. We do the calculations. That will be what? Minus 54 plus 18, that's minus 36. 6x minus 3x plus 3x. On this one, I can write it. And that will be what? 3x minus 12 over this. So if double prime equal to 0, then x equal 12. X equal 12, which is not in the domain of f. So my concern only about this. If double prime, this does not exist if x equal 9. And 9 is my border, so this is 9. Okay. Take a value less than 9, check this. This is positive because 9 minus something less than 9 will be positive. This will be negative, so that will be negative. So it's concave down from minus infinity to 9. And is there a point of inflection? No point of inflection. For clear, I need more space. طيب 24 f of x is it x plus 3 over square root of x. That will be 24. So it will be f prime. Well, first I can rewrite it as x to the power half plus 3x minus. Yeah. Now f prime would be half x minus half minus 3 over 2 x minus 3 over 2. F double prime will be minus 1 over 4 x minus 3 over 2 plus 9 over 4 x minus 5 over 2. So it will be, I can take minus 1 over 4 x plus minus 5 over 2 common factor. What's the remaining? The remaining here is x, and this is minus 9. So it is, this is 9 minus x over 4x to the power 5 over 2. By the way, what's the domain of the function? From 0 to infinity. 0 open. So if double prime equal to 0 implies x equal 9, which is belongs to the domain of f. So I have nothing to worry about it. So plug it. I have 9, and this is from 0, by the way. 0 open. Take a value between 0 and 9, take 8. It will be positive, and this is negative. So it's concave up from 0 to 9, concave down from 9 to infinity, and the inflection point, it's 9, and we substitute the original function. F at 9 will be what? Will be 12 over 3, which is 9. This is the inflection. Okay. 26, 2 cosecant 3x over 2. 2 cosecant 3x over 2. Which interval? 0 to 2 pi. 0 to 2 pi. Yeah. Okay. I know in the point of discontinuity will be what? I know f is not continuous. F cosine 3x sine, not cosine. F sine 3x over 2 equals 0. That implies what? That implies 3x over 2 equal n pi. So x equal to n pi over 3. Okay. Don't forget the interval 0 to 2 pi. That means I have x equal 2 pi over 3 and x equal 4 pi over 3. This is what I need to avoid. This is point of discontinuity. These are the points of discontinuity. Okay, now we'll do f prime. F prime will be what? Minus 2 cosecant 3x over 2 cotan 3x over 2 times 3 over 2. So it is minus 3 cosecant 3x over 2 cotan 3x over 2. Okay, this is f prime. F double prime. F double prime will be what? Now quotient product rule. Minus 3. Here I have what? Cosecant cotan. with a minus sign times cosine 3x over 2 times 3 over 2. Okay. Minus cosecant 3x over 2 cosecant square 3x over 2 times 3 over 2. And that give me what? Minus that give me 9 over 2. Okay. Cosecant cubed 3x over 2 plus cosecant 3x over 2 cosine square 3x over 2. In other words, that will be 9 over 2 cosecant 3x over 2 cosecant square 3x over 2 plus cosine square 3x over 2. And that gave me 9 over 2 cosecant 3x over 2. I know 1 plus cosine square is cosecant square. So that will be 1 plus cosine square. That will be 1 plus 2 cosecant square 3. Which is impossible to be 0. Impossible to be 0. Okay. So this is impossible to be 0. So I need to do my calculation or my checkpoints, only the point of discontinuity, which is 2 pi over 3 and 4 pi over 3. Okay. So I will check between 0 and 2 pi over 3. Take, for example, yeah, between 0. Well, what is the function? My function is this. This is always positive, nothing to worry about. So I need to check this only, which is like the sign. How it becomes that. Yeah, when you take 2 pi over 3 here, take, for example, pi over 3, that will be pi over 2. Cosecant pi over 2. No, it's not defined. What is this? Not 2 pi over 3. Take pi over 3. Pi over 3. That gives me cosecant 3x over 2. Take 2 over 3 to make it pi. Cosecant pi is 0. Make a problem. But it will be, yeah, it will be signed pi over 2, which is 1. That will be positive. That will be positive. Between 2 pi over 3 and 4 pi over 3, I'll take a value like pi. Pi give me 3 pi over 2, which is negative. Take a value here like what? 3 pi over 2. 3 pi over 2. It gives me what? 9 pi over 4, which is quadrant 1. That will be positive. So it will be concave up, concave down, concave up. So it's concave up from 0 to 2 pi over 3 and 4 pi over 3 to 2 pi. Concave down from 2 pi over 3 to 4 pi over 3. Inflection point? No inflection point. All of these are not defined, huh? The function is not defined there, so there is no inflection. Oops. Yeah. Next function, secant x minus pi over 2. Hopefully it's an easy one. Not sure. Secant between 0 and 4 pi. So it will be f prime Yeah, same complication. Secant x minus pi over 2 tan x minus pi over 2. F double prime will be what? Yeah, same problems. Secant tan, that will be secant x minus pi over 2 tan times tan square x minus pi over 2 plus secant x minus pi over 2 yeah, secant square, derivative of tan, which is secant square x minus pi over 2. So that will be what? I can take secant common factor. The remaining is what? Tan square plus secant square. As usual, 1 plus tan square cosecant square had impossible to be 0. So f double prime will not be 0. Be careful. You need to check when f is not continuous. If it's not continuous, f x minus pi over 2 will be equal. Yeah, when cosine yeah, cosine x minus pi over 2 equals 0, which is pi over 2 plus n pi. In other words, if x equal n plus 1 pi. Here we have the problems. Okay, so n pi, or yeah. Between 0 and 4 pi, I have what? So x so I need to avoid inside this pi, 2 pi, 3 pi. They plug them. So I have 0 open, 4 pi open. This is pi. This is 2 pi. This is 3 pi. Take a value in each interval for this. I notice this is always positive, so the thing is here. So take a value like pi over 2, it will be secant 0, which is 1, that will be positive. Take a value like 3 pi over 2, it will be secant pi, which is negative. Take a value 5 pi over 2, it will be 2 pi, which is positive, and that will be negative. So it's concave up from 0 to pi, and 2 pi to 3 pi. Concave down from pi to 2 pi, and 3 pi to 4 pi. Is there any point of inflection? No, no inflection point. Yeah, which is clear. There is no inflection point because all of this is undefined. The function is not continuous or not defined there. Okay. Now we want to do more problems. Let me finish. One problem more. Or let me stop here. I reached 28. I think I will stop here. I need to stop the recording too. Thank you.